Hello everyone and welcome to the Quantum Harmonics Oscillator tutorial. So what is Quantum Harmonics Oscillator? It's my new music sequencer which is essentially probability driven. So what does it mean for a sequencer to be probability driven? It means that you can create a music that is not totally determined by what you handcrafted, but has some randomness in it. So once you play it, it will generate some music forever without ever repeating. But this is not AI-generated music. This is generated music for sure, but it's generated out of a mathematical probability distribution that you can define and tweak as much as you want. Or my goal is to make it really possible to tweak it really precisely and enjoy this experiment of contemplating what happens when you press play. I am a one-person team working on this as an open source project, so I couldn't invest an infinity of time in it. It's where it is currently. It will evolve, it will become more and more complicated, more and more fitting feedbacks and things that are missing, things that you would have seen, I don't know, another way, or just leave me comments to make me think about how it could be better, and I would be really pleased to meet your expectations about these requests. But how can you try it out? It's really simple actually, because it's developed in Rust. The good news in Rust is that it's really simple to target either locally compiled native software, as you can see here, but here I'm in my web browser and I can visit the web version of the apps, fmath92.github.io/sound, and I load this same welcome page of the software. So you can try it for free, of course. It's a GitHub page, so thanks for GitHub to allow this kind of really nice possibilities to show something. Now let's dive into what can this sequencer do, because so far you have seen the welcome page. So let's explore first examples I made. Let's play an aqua reggae. A friend of mine told me it sounds really aquatic as a reggae. What do you think? Okay, I posted the few examples that I was satisfied with on this same YouTube channel. So if you want to hear it, it's aqua reggae. And what is important to say here is that I didn't choose all the notes that are played here. So I will try in this first tutorial to give you a sense of what does it mean for a music to be ruled by probabilities. Another example. So, at this point, some people expect normal music and they're extremely disappointed by what I'm showing. And some other are, okay, this is random, so this sounds quite okay for something which is random. So which team are you? Do you want to hear some music that musicians make and it's really nice because there are intentions in it, there are stories about this music band and stuff like this? I personally wouldn't listen to this music all the day, but it's really interesting to think about music as a probability distribution, I think, because when I started this project, I was, but this is really possible to make actual, to me it sounds a bit like music, only by defining probabilities, but then all the musics can be seen as a sample from probability distributions, don't they? So, for example, what probability distributions was Mozart? This is some kind of questions we can ask if you have a powerful enough tool to define probabilities, we can see every musical style as a probability distribution, and every music in this style as a sample from it. Okay, let's start with a new score here, and I will show you what happens if you add a new track. You start with the default sequence of notes. So no, not the default sequence of notes, the default sequence of probability for notes and rhythm. So if I leave it for 1 minute or 2, you won't ever hear the same sequence. And how does it work? If I click the track, I have panels that I can choose. Here I can choose the type of wave, like in any synthesizer. For example, if I choose the sawtooth, it really sounds like, I don't know, bad video game soundtrack. But then you can filter it. This is really a common process in subtractive synthesis, and it's slightly better. Then you can add some variation over time. So I don't claim it's really high quality subtractive synthesis here. It's not the point yet, because I've been working on this project for last 3 months, let's say. I didn't have really a lot of time to make every feature complete and achieved. But my main point was to focus on the generative probabilistic axis. So, okay, I will go back to the sine wave because it sounds really better to me, at least for experimentations. And let's focus on the rhythm first. For the rhythm generations, there are 2 key concepts here, which are inclusions generators and exclusion generators. Both can be either probabilistic or deterministic. We'll start with deterministic version of them. Here I will add 1 inclusion generator and listen to what it does. Yeah, it's a really, like, it's not even a rhythm. It's a sequence of notes with no special rhythm. But I can add some more generators. And what does it do? It won't just pile up notes. You can add some more generators. You won't have chords because of that. Okay. So now how is the tick set? So of course there is a tempo here. So here it's 60 beats per minute. So 1 beat equals 1 second. And the time quantum, which is how much I split each beat for these ticks, is 1/8 of a beat. So here 1 time quantum will be 1/8 of a second. And I can also add exclusion generators, which is, so all the multiples of these numbers will be starting new notes, except the ones that are found in this list here. So there is one subtlety. I don't want to exclude the first times of the sequences. So I shift by 1. So here, even if, for example, there is 2 in the inclusion generator list and also 2 in the exclusion, it doesn't mean necessarily that these 2 will erase that one. Okay, it's shifted by 1 to avoid suppressing the first beat, the first tick. So for example, I can exclude 5. It will be a bit like what I had before with less notes. And now it starts sounding a bit like, it's not random, because from one sequence to the next one it will be the same rhythm, but it's hard to understand the pattern already. But I can go further with, for example, saying that the exclusion generators will now be 5 numbers picked among 1, 2, 3, 4, 5, 6, 7, or 10. I could go higher here. I could pick less generator or more generator. Of course, I can't pick more than 14 generators among the 14 first natural numbers, I mean. So there are tooltips that explain it a bit better than I'm doing it right now. And there is also a README here. You can click the README, read it. It's really long and precise, I hope. But maybe it's not the best way to handle the tool, but maybe just by trying it out. So now I have these exclusion generators. I have 10 exclusion generators among the 14 first natural numbers. So most of the notes will be excluded. So I have like this kind of long notes, because what I'm talking about here is not the notes themselves, but when they start. Like, and one note will last until the next one starts, okay? I could also make the inclusion notes random. That's pretty much it for the rhythm. Another part is the harmony. Here I have a tolerance parameter that defines the time window in which I will look for already generated notes. Here I have only one track, so the only already generated notes that can be found when, for example, this note needs to get generated is the previous ones of this track. But if I had multiple tracks here, it wouldn't be the case anymore. For example, this note here will be able to find notes in this region if it overlaps its time window, but also in this region here, because the first track is generated before the second one. And okay, I will delete this second track for the sake of this example. Now what happens when we have defined this time window? We find some notes, it's expressed in beats. So here 1 beat equal 1 second, and I think one sequence here is set to be 4 seconds. So roughly the region will look like this: 1, 2, 3, 4, 5 notes maybe. With this method of harmony generation, it will pick one in the time window and it will apply variations to it. So to apply variations, I can define variation intervals here, which can be in this example unison, an ascending fifth or a descending perfect fifth in both cases. I could have a diminished fifth or an augmented one, but yeah, let's keep it simple for that example. And now this variation will not only be applied once, but here I set it to twice. If I find the note, I will maybe take its ascending fifth, then a second time an ascending fifth. It will lead to an interval of a second, because the fifth of the fifth is a second. So you see here, even if I set some limited set of intervals, if I go to high number of variation steps, I can reach notes that are a bit far in the fifth cycle scheme, for those who are familiar with that. So for this way of generating harmony, it's pretty simple. Just remember that there is this time window here, which will be really important. For example, if I say, okay, I just allow no variation, what happens? Okay, only one note. Now if I allow an ascending semitone as a variation, and still one note, because there is 0 variation steps. But if I go to 1 variation step, so what happens here is pretty interesting, because you see here, because of the time window, it can go back in the past and pick one note which was here, for example, to make a variation of 0 as an interval. So it snapped back to the value which was found here. Okay, now if I have ascending and descending intervals, not really melodic, but it sounds logical what it does. Now there is another way to generate harmony, but okay, this will be a whole video about that. But I just want to mention it's possible to make you hear how it sounds. It's the harmonizer option. I will leave this track as it is and harmonize a second one on the first one. It also has a time window, which is defined the same way as the other case, but the harmonizer works another way. It defines tensions between every possible unsigned intervals. So if you see a note as a degree from 0 to 11, you can wrap around 12 and make difference between these degrees. So the maximal difference will be 6. I define the tensions between all of them. So ascending and descending is the same in this vision. I could have done differently, but it would be a bit absurd in some context I don't want to discuss here. But it's definitely possible to do it. Now I'm trying to generate this note, for example. So I'm considering all the notes in the time window from the same tracks and above. And I'm trying to minimize the sum of all the tensions that are mapped to each interval. It's not the point in this video. I just want to show you that this possibility exists, because it makes it possible to do something like you will go deterministic in the generators. The time quantum will be 1 beat only. Inclusion generator will be 2, and it's going to be the only one. So here I will have one note every 2 seconds. Okay. And this will be considered as a chord chart. So I will mute it. There are 2 different ways to mute a track in this software. You can either mute it like that. You can also solo it. Here I won't do that. The wave type will be silent, nothing, it's mute. So it will generate notes, but these notes will be at volume 0, we can say, because the point of this track is to play the role of a chord chart. I will maybe put 3 of them, so it's really a chord, 3 notes at the time. And this one harmonizes on the what already exists. And now what we can do, I can ask it to generate not only 1 note at the time, but let's say 3 at the time. So it will try to find the set of 3 notes, so the chord that minimizes the tensions with respect to the already existing notes. So we can roughly speaking say with respect to this chord chart in blue here. I can ask the software to arpeggiate the chord, once again in the units of time quantum that was defined in the rhythm panel. Or I can go higher in the time, the space between the notes. Okay. So I think it's already a lot for a first video, but what I'm really interested in is, do you think there are use cases in which this approach is really interesting in terms of musicological experiment or in terms of soundtrack that has to never stop in an installation in a video game? For example, you are playing a level, you don't know, as a game developer, you don't know how long the player will spend in your level, and you want the player never to hear the same music again and again. Or I don't know, you're meditating and you want to hear all the time new music, you're studying and you want non-repeating stuff. Assuming we have something a bit pleasant to hear, Do you think it's something you would like to use or not? You can let me know in the comment and we can discuss it. Also, do you think it's real music? Do you think that is an instrument? Do you think it's just robotic bullshit you don't want to hear about because only real instruments matter in life, which is pretty much what I was thinking when I was younger, but everybody changes his mind at some point. When I started developing it, it was to try to see music as a sample from a probability distribution once again. Like, what makes classical music definition as probabilities? I think it would definitely require some much more advanced way to set the probabilities than what I developed so far. But my goal is to go as far as I can in that direction so that we can maybe reproduce musical styles. There are also many options that I didn't talk about yet, but I will leave it for a next video. So, okay, if you enjoyed listening to this kind of experiment, I will try to make some new videos about other stuff of the software as it will keep evolving. Also, if you have requests about features that you would like to have in the software, don't hesitate asking me, because right now I'm really trying to produce the ideas, but also to implement them, to test them. It's a lot of work. So if you have ideas or whatever, you think something would be really useful to have, maybe it's easy to implement, maybe it's not. If it's easy to implement, I will really try to make an effort putting it in the software. If it's not, I will really consider it. Also, if you want to join the project, it's an open source project, so I hope one day I won't be the only developer in this team. So yeah, that's it. Goodbye.